Hi there, this is your Monday science video, and we are on the last chapter, chapter 13 in your book, on page 201 if you want to follow along. Now I'm going to be covering a little bit more information than I normally do so that we finish this chapter in 3 lessons, so Monday, Tuesday, and Wednesday. And the reason is because when we get back to school, I want us to be done with science as we won't be moving back and forth in between classrooms. So I really want my first, second, and third graders to get to finish the book with us. So it's really important that we get finished this week with the notes so that you will have seen every page in this book. And that's really exciting. So you can follow along. If you are in a junior journal, you can do one of the coloring pages for the last chapter, or you can take notes, or you can do both. It's up to you how you do this last chapter. They can be really long, so if you are like really burned out on taking notes, then you can switch over and you can color. Now my journal level, and for my 4th grade through 6th grade, I want you to be taking notes in your note pages in your journal. Okay, so let's get started. Lesson 13 is other interesting aquatic animals. Well, your study of aquatic creatures is nearly complete. You have gained a world of knowledge, but there are still more critters to be discussed. Some scientists call the animals we will study in this section simple animals because they do not have some of the body parts that we normally think animals should have, such as eyes or ears. Others, like the tube worms pictured there on page 201, really look like plants, never moving anywhere. Still others are so tiny that you need a microscope to see them. You can go ahead and look at those tube worms. They look like plants, don't they? But they're actually animals called tube worms. You may be wondering how a scientist knows if a creature is an animal, a plant, or something else like bacteria. Well, when examining an animal under a microscope, scientists can easily tell if it's a plant or an animal by examining the cell, or the cells that make up the creature. If you do not know what a cell is, it is the basic unit of every living creature. So plants and animals both have cells. And so we're going to look under our microscope, so we have to zoom in. So what might be that big, which you can't see on the video, if we were to zoom it in on a microscope and pull it up really big, we would see a cell. And a cell is the basic unit of life for a plant or an animal. Okay? Anything that is living must have at least one cell. Of course, if it only has one cell, you can't see it without the help of a microscope. The animals you have been studying in this book are made of many, many cells, which is why you don't need a microscope to see them. I'm living. You don't need a microscope to see me because I have a lot of cells. Okay? You have a lot of cells. But if you only have one cell, if an animal or a plant only has one cell, then you can't see it with your eye. You have to look at it under the microscope. Animals and plants are made up of many cells. As a result, we say they are multicellular. Multi means many, so multicellular means many cells. Multi means many cells. So you are multicellular. In fact, if animals and plants are made up of many different kinds of cells, In fact, animals and plants are made up of different kinds of cells. An animal's skin is made up of one kind of cell, while its heart is made up of another kind of cell. There are other creatures, like bacteria, that are unicellular, which means they are made of only one kind of cell. These creatures are so small that you cannot see them with the help of a microscope, but they are indeed living things. So, to be an animal or plant, a creature must be multicellular. If a multicellular creature consumes food and has the ability to move on its own, it is an animal. You see, animals are consumers. They must consume food to live. Plants do not move around and do not consume food. They make food. Because plants make food for themselves, we say they are producers because they produce their own food. So if it's an animal cell, we would say it's a consumer. because it consumes food. Okay? If the cell was a plant cell, plants make their own food, so they are called producers. Okay? If you think about going to the store, we, the animals, consume the produce section, which are the plants. Okay, so it's a good way to help you remember that information. Let's see. Okay, on page 202, have you ever seen a plant walk around? No, because plants cannot move around. Do you know what a mobile home is? It is a house that you can move around to different locations. The word mobile means that it can move from place to place. Animals are mobile, but plants are not. So how would you describe an animal? See if you can do it. As you just learned, scientists say that an animal is multicellular. Okay? It is a mobile consumer. That's the definition of an animal. Sounds kind of scientific, doesn't it? Can you tell me what each word in the definition of an animal means? Multicellular and consumer and mobile. Okay, so now let's move on to sponges. If you were scuba diving in the ocean and came upon the things pictured on the left, would you be surprised to learn that that you were looking at animals? If you look at the picture of the sponges on page 202, they look like some sort of plant. Okay? They are called sponges, and there are thousands of different species in them in the ocean. You probably have used sponges before. Most likely you have used them to wash dishes or even wash yourself in a bathtub. Although the sponges you have used were probably synthetic, meaning that people made them, they are actually modeled after these soft, squishy animals. Actually, not all sponges are soft and squishy like the ones we use. Some are hard and prickly. Sponges come in many shapes and sizes. Some are as tiny as your finger, and some are as large as a shower stall. Really tall. Some look like tubes, while others look like tree branches. They all look more like plants than animals. A sponge has no eyes, no ears, no brain, no nerves, no heart, no blood. As an adult, it spends its entire life attached to an underwater rock, never moving from that spot. When something is stuck to one spot, we say it is sessile. Sponges are sessile. S-E-S-S-I-L-E. Sessile. But even so, sponges are not plants because they still are consumers. Let's see. Still, they do seem rather unanimal-like, don't they? In fact, at one time, sponges were thought to be plants by scientists. This just goes to show you that scientists are still learning things. As a result, they sometimes change their minds as they get more information. So what's the purpose of a sponge? As consumers, what do they consume? Well, God's great purpose for a sponge is to clean. Isn't that funny that we use sponges to clean in our house, but the job of a sponge in the ocean is also to clean? Let's see. They don't just clean our bodies and our kitchen counters. Sponges actually clean the ocean. They are some of the most important filter feeders that God made. Do you remember what a filter feeder is? It's an animal that filters its food out of the water. Well, most sponges filter bacteria, algae, filth, and debris out of the water, and they release clean water back into the ocean. This is a valuable service because those things cloud the water. In other words, most sponges are living filters that keep our water clean. They are such dedicated cleaners that a full-grown sponge can filter as much as a bathtub full of water every hour. So think about your bathtub full of water, and once an hour a sponge can clean all of that water. Sponges are sessile when they are adults, gluing themselves to hard surfaces and staying put. However, when they are larvae, they do move around. A young larval sponge can swim, but not strong enough to overcome the currents. Thus, it is part of the plankton, floating around until it settles onto a hard surface which it can glue itself to. Sometimes the tiny larval sponge might settle on the hull of a ship, the back of a crab, or the shell of some other animal. If this happens, the larva will glue itself to the surface and grow into an adult sponge. In this situation, the sponge might end up moving around as an adult, but the sponge really doesn't move around. It just moves around on the back of whatever it glued itself to. It is just carried here and there by the ship or animal. So you now know that a sponge isn't always sessile. It is mobile, but only when it's in larval form. Sponges grow in both the salt water of the ocean and in the fresh water of lakes and slowly running rivers. They can be found in both warm waters and freezing polar waters. They can be deep in the ocean or right near the shore. Wherever they are found, they play a very important role in keeping the waters clean. A full-grown sponge may be 2 inches long or 10 feet long. That's probably the length of your bedroom. Look at these divers on page 203, looking into a large barrel sponge. Either one could stick his head right inside if he wished to do so. Would you like to do that? It might seem like it would be fun, but you really wouldn't want to do that, and you'll find out why in a moment. Look at that picture. Isn't that really neat how they're looking at that barrel sponge? You have an outer layer to your body, and it's called skin. Well, a sponge has an outer layer as well, and it's called the penicoderm. Can you say that word, penicoderm? This outer layer is riddled with holes or pores. In fact, sponges are put in phylum Porifera, which means pore bearer. To be scientifically correct, the holes are actually called ostia. What do the ostia do? Take a guess. The ostia work like hundreds of tiny doors that open to let water into the sponge. You see, cells called collar cells have little tails that flap back and forth, creating a current that pulls water through the ostia into the sponge and out a hole in the top of the sponge. The water that the ostia let in has oxygen and food particles in it. The cells of the sponge absorb the oxygen they need from the water, and the collar cells have tiny collars that trap the food particles carried in by the water. The food is absorbed by the collar cells and transported into the entire sponge. Once the food and oxygen are consumed, the now clean water is pushed upward and out of the top, where it exits through a large hole called the osculum. When small sea creatures find the osculum of a sponge, they'll sometimes swim inside and make the sponge their home. This works out well for these creatures because the sponge allows them to hide from predators. There they live safely protected, eating other creatures that swim inside the osculum. There are times when a small animal swims inside a small sponge osculum and grows so large while living there that it can't ever exit again. It's too big to get out. It is trapped inside the sponge. Most sponges have many different kinds of animals and organisms, making the sponge their home. One large sponge was found to have more than 1,000 organisms living inside it. Defenses. Although a sponge can't move once it has attached itself to a surface, there are parts of the sponge that do move. The cells surrounding the ostia can force the ostia to close, which prevents water from entering. This keeps bad things such as poison or anything else that might harm the sponge from entering the sponge. This then is one way the sponge protects itself. Some sponges also have the defense of an offensive odor or a disgusting taste. This odor lets a potential predator know about the taste. Most animals won't eat stinky sponges, but not all sea creatures dislike the taste of a stinky sponge. Sea stars, snails, and some fish actually enjoy a spongy meal now and again. Another defense that most sponges have is composed of many tiny sharp spikes that are situated throughout the body. These spikes are called spicules. So you kind of hear the word spike in there, spicules. They are actually the sponge's skeleton. They give its body shape and firmness, but also help to discourage other animals from eating the sponge. Are you glad that you don't have tiny spikes in your skin? Predators learn to stay away after getting a mouthful of spicules. These thorny spikes are why you wouldn't want to climb inside of a sponge, even if you could fit. Not all sponges have hard, sharp spicules, however. Some sponges are soft, and if you use a natural sponge for cleaning or for artwork, these are the ones you are using. Actually, when you use a natural sponge, you are not using a living sponge. You are using the skeleton that a dead sponge left behind. And tomorrow, we'll talk about sponge assortments and some sea squirts.